Okay, so in this question we have to prove that this LHS portion sin a minus cos a plus 1 upon sin a plus cos a minus 1 is equal to cos a upon 1 minus sin a. This is what we have to prove in this question. So as we do in any other question of proving, right, let us start with LHS. LHS is given as sin a minus cos a plus 1 divided by sin a plus cos a minus 1. Okay, but now this is a particular question in which we directly don't get some idea where to begin, right? So one thing that which can be noticed in this question is, if you take these two terms, if you look at these two terms and take minus common, just minus, you will get sin a minus of cos a minus 1, and division will be with again the same thing, sin a plus cos a minus 1, right? So now things look a little better, because we now have two quantities, sin a and cos a minus 1. In numerator they are connected with a negative sign, in denominator they are connected by a positive sign, right? So whenever you get something like this, one thing you can notice is that if you multiply by either denominator quantity or the numerator quantity, you might get some simplified result, right? What I mean is that in this particular question I want to multiply whatever is written in the denominator, right? But if I have to multiply whatever is written, sin a plus cos a minus 1, if I multiply something, I will have to divide by the same quantity, because I don't want to change the value of the expression, I just want to modify it, right? Okay, so what happens now, if you can observe, the numerator quantities are a minus b into a plus b, which is the formula of a square minus b square, right? So numerator will convert to sin square a minus cos a minus 1 whole square, a square minus b square. And what happens in denominator? In denominator we have two exactly same brackets, sin a plus cos a minus 1, so this will become whole square. Here you will get sin a plus cos a minus 1 whole square, correct? So let us try to open these brackets and simplify further, right? So what will happen? You will get sin square a in the numerator, sin square a minus cos square a minus 1 plus 2 cos a. This is what you will get because of the minus sign, right? And what happens in denominator? In denominator, if you open, you will have to use a plus b plus c whole square formula, right? So in that case you will get sin square a plus cos square a plus 1 plus 2 sin a cos a minus 2 cos a minus 2 sin a. This is the expression you will get after opening the brackets, right? Now further let us try to simplify this expression. What will happen now? Now in the numerator, let us observe, numerator is what? Sin square a minus 1. What can this be written as? If you look at the original identity of sin square and cos square, we have something like this, sin square a plus cos square a should be equal to 1, which means that sin square a minus 1 should be equal to minus of cos square a, right? So let us combine these two and write minus of cos square a, but there is already one cos square a here, which means that I will get 2 cos square a. So I am just removing these two quantities and multiplying 2 here to simplify, right? What I will get? Minus 2 cos square a. I also have 2 cos a present here, but let us take that on the later step. Okay, let us look at the denominator now. In denominator I have sin square a plus cos square a, but sin square a plus cos square a is what? It is equal to 1, and I also have one more 1. So what I can do is I can leave out this expression, write it as 1 and add with this one to get 2, right? So first thing which you will observe is that 2 will get cancelled from numerator and denominator because every term contains 2, right? So now if you look at this expression, let us look at the numerator again. I can take 2 cos A common. If I take 2 cos A common, I will be left with 1 minus cos A inside, right? And what happens in denominator? In denominator, I will have to factorize very carefully. Let us take this term 2 and minus 2 cos A. If I take 2 common from this, I will get 2 into 1 minus cos A, correct? And what will happen in if I take these two terms? If I take 2 sin A common, or even better, if I take minus 2 sin A common, then I will be left with 1 minus cos A again inside the bracket, right? Now I can further factorize this quantity in the denominator. If you look at it very carefully, you will get 2 cos A into 1 minus cos A in the numerator, which is already there, and denominator is what? If I take 1 minus cos A common, I will be left with 2 into 1 minus sin A, right? So what all things are getting cancelled? 1 minus cos A bracket is getting cancelled, your 2 is getting cancelled, so you are left with what? Cos A in the numerator and 1 minus sin A in the denominator. So overall your expression becomes what? Your expression becomes cos A divided by 1 minus sin A, and this is equal to your RHS value, hence proved.